Hello guys, today I'm going to be demonstrating some of the capabilities of scripts in the GhidraScriptShed. It's just a small collection of scripts I created while wanting to get into GhidraScripting. None of them are super high equity. It's kind of just me learning, and these are scripts that I found useful in my own research and studies. As you can see, not many of them. There's only 5 in here. And most of them are rewrites of scripts that are already out there. I just kind of did some changes on them and put them in here because I like them. But there is one that I worked on myself. So, without further ado, I'll start off by showing the PreviewFunctionCapabilities script. It's a modified version of script found at that link. What it basically does is it analyzes undefined functions in a binary, and it generates meaningful names based on their capabilities, such as network, file, or thread operations, using peak code analysis for cross-architecture support. So basically what that means is it will go through and look for specific APIs, and those APIs are dictated by these dictionaries that we have in the script here for both Windows and Linux, and it's based on several different categories. And it'll look for these APIs, and it'll rename the function to include something like this, where it's like the general category and the type of operation it's doing. So instead of having like all these specific APIs, it'll kind of just tell you if it did both a listen and an accept, it'll just say a network listen. And that is defined more so by this base categories and Windows and Linux categories dictionaries here. The original author has like a much better explanation on it, and he has a whole YouTube video on it, so check it out. Again, I didn't do any like super radical changes except for maybe including some more APIs, and anything covered in this changes thing here. But to use it, pretty simple. First of all, I'm going to be using the binary that was used in the blog in this link here. It's the original author of the rename flux by logs script by a different name, obviously. But I'm just going to be using that binary in this demonstration. So I downloaded it. That blog goes through downloading and extracting the specific binary that we're going to be using, which is SOAP server D. So yeah, I've only just imported it here. I'm going to run the auto analysis on it, and kind of be checking out the symbol table. And as you can see, it has a bunch of undefined functions. 175 that if we were looking at, we would have no idea what they're doing, right? You would have to go through and see like all the calls that it's making and check out the analysis, the decompilation. So PreviewFunctionCapabilities will help us with that. So let's talk about installation. If you download the repo, you'll have it in like a directory, and you can add it to the script manager here to where it just shows up like this, and all the scripts are in one place. Just go over that really quickly. These are all your GhidraScript directories where Ghidra will look for scripts. But if you wanted to add GhidraScriptShed, you would just go to that plus sign there, look for the specific directory that you installed it in, click OK, and then just refresh, and it'll show up over here. Now you can run all these scripts. But yeah, PreviewFunctionCapabilities, just run it. It doesn't take any options. And right now it's looking at 175 undefined functions, and it's going to the leaf nodes, seeing all APIs that it calls, trying to find like the categories, and then it traverses up kind of that call tree, and also renames the parents based on what it's the child nodes call. It appends the PFC string to the beginning of it. It prepends it, so you can easily search for them in the symbol table. You can see it's pretty beefy names, and we'll go over a little bit on like the convention that it uses. There's a lot of string and memory manipulation APIs in those dictionaries that I showed earlier, which makes it pretty verbose. And you can see here is if verbose funcs is set, it'll add those more verbose APIs. And if you don't want those in there, set this to false and just rerun the script. The good thing about this is that you can easily undo all the changes done by a simple click. But I'm going to get rid of those more verbose APIs so you eliminate some of that noise. So yeah, as you can see, much simpler function names. Going over like some of the generic categories that it uses, we can use some examples. Now this is a pretty decent example. So it looks like this function, if you just by looking at the name of it, doesn't call anything itself, but its child, the functions in its call tree end up calling process execution API, listening API, string duplication and finding APIs, some signal handling stuff, and this function itself has 3 references. That's what xref is. And the way I know all these is the original author has a video on it, but also, like I showed earlier, it's just this, and it'll tell you what the specific letters stand for. But none of them are uppercase, so you know that this function itself didn't call them. Its children did. So as you can see here, its child, this is the child that actually called that process execution API. Which if we check out and look for it, it looks like it calls system. So yeah, it's just like a good general overview of what they're doing without having to super dive deep into all of them. Moving on to the next script, as you might have noticed that the setup is a little bit different. The video cut off, and yeah, I'm working with Xbox Game Bar here. I don't ever make videos, as you might have noticed by now, but I just felt it was super important, super useful to have a video walkthrough of this stuff because I like video walkthroughs. So anyways, I'm gonna move on to the SourceSinkSleuth script. This is the one that I made myself. Originally, it was intended to look for paths where potentially attacker-controlled data is eventually input into a dangerous sink, but it turns out the taint tracing is pretty tough to do, and there's already some decent alternatives out there, which I linked in here, and those are just like some quick research stuff that I found. But what it actually does is it takes a source function name and looks for a code path from there to a sink function of your choice. And those are listed in the FOI dictionaries. FOI stands for functions of interest. And you can either search forwards or backwards, and there's like a scenario here. And it'll display nicer on GitHub, the mermaid diagram. But go ahead and check that out. It kind of explains the logic behind SourceSinkSleuth. But if we check out those FOI dictionaries, FOI, they're here. They're much smaller than some of the dictionaries and some of the other scripts, because I just wanted to check out like more interesting APIs. And then you can also add your own here. you would just put in your own APIs and they would show up in the user interface and you could check for them. So yeah, let's demonstrate it. I am going to remove the renaming for these functions because those names get super long. So the output of the script will be like really messy if I don't. But we'll just use the original names. Oops, cancel that. Don't want to do that. Yeah. Let's run PreviewFunctionCapabilities. Let's not run PreviewFunctionCapabilities. Let's run SourceSinkSleuth. Okay, so you can give it a target function. This is the function where it's gonna either look backwards from or look forwards from. Let's just use, oh my goodness, this thing still renamed the functions. Attempt number 5 here. This is the function that it will either look forwards or backwards from. So let's use this function here. Fun0149F8. Our recursion depth limit, the default is kind of arbitrary. It's kind of like, so this uses recursion, and you don't want to be stuck in an infinite loop or like used up too much resources, so you can use this to prevent that. It's after about 3 recursions, the amount of correlation between like the original function and any functions of interest, like any special relationship that might be there, gets like smaller and smaller. Like the chance of something like interesting being there is less likely. So I mean, you could do 3 or 2 if you'd like, but I'm gonna stick with the default. And you either search forward or backward. Default is backwards, but I would like to search forward here. And yeah, let's check it out. So here you could choose all the functions that you want to look for. Maybe I want to look for writes and jmods. I'll look for all networks and all code execution, and maybe some string concatenation. And it'll go through, look for those, find paths to them. So I found a path to system from our function here. Listen, socket, bind, and accept. And if you notice, this is the same function that we were checking out earlier with the PreviewFunctionCapabilities, and all of these were called in there, so it's not a huge surprise, but it's kind of a little demo here. So here's a code path to system from the first one to 158, and then this calls system here. So it's kind of more like navigating the code tree. So instead of you going through all these and manually like expanding all of them and seeing if they call like read or like bind or anything, right? Anything interesting, this will find that for you, and then you could just go down that specific code path and check out that specific function call graph in the window here. So yeah, nothing revolutionary, but it's helpful. At least for me it was. Okay, moving on to the rename funcs by logs script. This has been done many times. I've seen a bunch of scripts, but I will base mine on the one by Conviso Labs at this blog post here. But basically, a lot of times embedded IoT binaries have like an external function that they'll call to log to, And if it's external, it's great for you because unless they import it by ordinal, they can't, like, even if the binary is stripped, it'll have that name in there. In this binary's case, it's log, so it's super easy to identify. But let's say that there wasn't no easy logging function name. What you would do is you would look at, this is one approach, obviously. You look at the symbol table, filter by reference counts, and then you could start by the most reference and go through all those calls to it and see how it's used. Kind of imagine that the name isn't there, right? Imagine it's some generic name, and you could check out how the functions call it. Like this one's pretty obviously not a logging function. Actually, not obviously not a logging function. That might be a pretty good candidate, to be honest, if I was looking for logging functions in the dark. This one is definitely not a logging function. And this one is a very good candidate. See, it has like a varying function name here, and then like some format strings and arguments to that. Very good candidate. So yeah, obviously this is our logging function. Once we've identified the logging function, we'd finally use the script here. It takes the name of the logging function, which in our case is log, and the index that the function name, the calling function name is given in. So in this case, it would be 0, 1. And we'll get into aggressive mode in a bit, but I recommend always using aggressive. And we'll do verbose so I can talk to some of the errors and intricacies of the output here. Notice there's plus signs, which means some kind of success message. These are warnings and errors. So warning, unable to get function address from beep code at blah 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 address. A lot of times when that happens, it's because it's an indirect call, an indirect jump, and I didn't worry about trying to account for that, because if you check it out, it's never like a logging function. Like it's never going to be a logging function, so I don't care. I just ignore those. This one is more interesting though, because this function called log 4 times, but we were still unable to deduce some kind of argument for it, right? And you see that I'll use the same memory in the data region of the binary, and if you check it out, you can see that the auto-analysis failed here. Failed to determine it was a string, so if you just tell it that it's a string, it'll fix up, and the next time that we rerun the script, it would identify that and rename it. But that's you kind of just go through this manually and look for any errors. Here's a warning that only shows up because of verbose mode. Normally it would just do this without telling you about it, but this function had multiple name candidates, and these are the name candidates and the amount of times that they were used. This one was used 256 times, so it was eventually renamed to that, which makes sense. Let's see if there's any more instances. Yeah, so this one, soap main, used that 1,192 times, another one's a couple times, so you know, aggressive mode just kind of uses the most popular one. And it also does things like handle duplicate names, because Ghidra for some reason lets you name multiple functions the same thing, and that gets confusing. So if there's name duplicates, Ghidra will append the address of the function at the end here to kind of get rid of those confusing names. And this is that same function that we were looking at earlier, main, which had that messed up string in there. So yeah, 80 functions were renamed. You don't have to look at these ugly names anymore, thanks to them calling the logging function with the name. Yeah, it's super helpful. Some binaries I've renamed up to like thousands of functions names at a time, so it could be pretty useful. And next, I'm going to move on to Rhabdomancer. So Rhabdomancer and Haruspex were created by Marco Vivaldi. And what this one does is it locates all calls to potentially insecure functions, which have been classified in 3 different tiers of decreasing potential for exploitation from 0 to 2. So if we check out what it uses in the back here, tier 0 ones are like most interesting for exploitation, and you can go through and modify these if you'd like. But then there's tier 1 and tier 2, and then it has like Windows ones as well. But it goes through the binary, looks for that, and allows you to either comment or bookmark them. The original kind of didn't give those options, kind of just did it. But I'm going to use both, just kind of showcase them. And you could choose. I always like to choose all of the more interesting ones. Maybe some of the tier 1 process APIs, all of them. All of the network ones, it's always good when looking at IoT devices. Maybe some dupes. SRAND, like look for potentially insecure uses of random. I could add some crypto ones in here. I probably should at some point, but yeah. Super configurable, you can do yourself. And yeah, it lists them by default, but you can also comment and bookmark. You can go through like these specific calls, nothing crazy, but check out the comments. You can filter for them. As you can see on the decompile window, it uses it prepends RM for Rhabdomancer, and then it goes by tier and the actual thing that was called. So you can filter like that. And then the bookmarks tabs, you can see they're not here. You have to enable the Rhabdomancer type. And then you can, filter by type, the category. Yeah. And the good thing about this is that you can always just undo it with a single click. But I like to keep them on, especially the comments, to showcase. And our next tool, which is Haruspex. Nothing super crazy. It basically just writes everything in the decompile window to disk. So if we were to run that right now, it'll tell you to select the output directory. I have this one set up. And it says extracting X amount of functions. And if you kind of open that up in some kind of IDE, you can check out the code like that. But the more interesting use of this would be with things like static code analysis tools like SemGrep. The original tool author has a blog post talking about how he used this script and worked with SemGrep to find some cool stuff. He also has his own SemGrep rules that he lets the public use, and I've used them myself. Pretty good stuff. Shout out Marco. But yeah, pretty interesting stuff. Let me know if you have any questions, you want to fix anything, some pull requests. I probably won't be too active, but we'll see what I can do.